so this one is also pretty straightforward. This is one pretty easy problem. So we have a Jeep, going over a curve. So notice it asking for determine the maximum speed that the Jeep can travel over the crest of the hill and not lose contact with the road, so that it doesn't like fly out of the curve. The only thing that we're given here for this Jeep, it's the radius of curvature, which is 250 feet. So it's constant. And they're asking us to find the velocity, right? What will be the maximum speed it can attain before this car will, fly out of the curve. So what is the minimum velocity? Or the maximum velocity it can attain before it does that. All right, so as always, we'll do our free body diagram. So our free body diagram for the Jeep, I'm gonna do this block right here. For the front, what forces do we see? Well, we have the weight of the Jeep, we have the normal force right here, right? And in this case, if we analyze this, right, if it's touching is normal force, but if you're asking for the maximum speed that you can travel and not lose contact with the floor, every time we see something like that where it doesn't lose contact, we basically do it as if there's no normal force acting, right? Just what is the velocity? If this was not touching it, right? If this was actually elevating, right? Let's say actually it's flying out. What is that velocity? So whatever we'll get, that will give us our maximum velocity that will make this car fly. So if this car does indeed fly out of the curve, that means that it's not touching, so there will not be any normal forces right there. So once again, every time we hear about not losing contact, we might see that in our problem later. Losing contact, we can then remove the normal force out of this equation and just consider the effects due to gravity. So let me write down then the direction. So this will be the tangential direction of velocity, and of course this right here will be the tangential or the normal direction of the motion over here as well. So then this problem is almost done. So we'll do summation of forces in the normal direction equals to mass times acceleration normal, or equals to mass times velocity squared divided by rho. Once again, notice we don't need most of this information because some of those stuff will be canceling out. So the only force that we have in the normal direction, that is weight, so mass times gravity, is equals to mass times v squared divided by rho. Notice the masses will cancel out. We do know gravity, we know rho, and we can solve v squared out of that, where we're going to get out of here, right, that v squared is equals to gravity times rho. So when you take a square root, we'll get that velocity for this car will be a maximum of 89.72 feet per second. So it's here pretty fast, right? This is the maximum velocity it can attain before it flies out. Once again, considering that there's no normal force, it's already flying out, so the velocity it can attain should be below this value. Anything above this, already the normal force is non-existent, so the car would just fly out of the curve once it passes that curve.